So in this session, we will do the structure question related to nuclear atom. Yesterday we did the MCQs, multiple choice question. Today we'll do the structure questions related to the nuclear atom. So as we know, every matter is consists of atoms, and atom consists of neutron, proton, and electron. The central part of an atom is the nucleus. Around the nucleus, electrons are moving, and overall atom is neutral. And we can represent the element by symbol A, X, and Z, which is called a nuclide notation. A is representing a nucleon number, Z is representing a proton number, and X is a chemical symbol of that element. So in this question, as you can see, the chemical symbol of the element lithium is Li. So they mentioned that lithium is Li. The proton number of the lithium is 3. So figure 9.1 represent a nucleus of a radioactive isotope of lithium that is about to decay, because radioactive isotopes, as they are not stable, they will decay, emit out radiation. Write down using a nuclide notation a symbol that represents this isotope. So first thing, as we know, when we represent any nuclide, the symbol is A, X, Z, or X. A is representing a nucleon number. Nucleon number is a sum of neutron and protons. So how many neutrons are there? As they already mentioned, there are 3 protons. So basically the shaded part are representing the proton. So this is proton, proton, proton. And the circles, the unshaded part, are representing the neutron. So what is A here? A is the sum of neutron and proton. So according to this figure, how many neutrons are given? 1, 2, 3, 4, 5. So 5 neutrons are there, and how many protons are there? 1. This is proton, proton, and proton. So 3 protons. So 5 plus 3, 8. So when we represent in terms of nuclide notation, the X is a symbol of the nuclide. So Li, where A is equals to 8, the sum of neutron and proton, and Z is equals to number of the proton, as they already mentioned, it is 3. So it will be equal to 3. So the symbol will be 8Li3. So when we describe the structure of a lithium, the nucleus consists of 3 proton, 4 neutron, and 3, where proton number Z is a proton number and the nucleon number is A. And we already discussed about the isotope, same atomic number but different atomic mass. Figure 10.1 represent a neutral atom of an isotope of element X. So element X isotope is given. State one similarity between this atom and a neutral atom of a different isotope of element X. Like, what is the similarity between the isotopes? How the isotopes are similar to each other? So we can say they will have the same number of protons. We have to write only one similarities. So we can mention protons or electron, any one of them. So when isotope, that's a common thing for all the isotopes. They will have the same number of proton and electron, but they will have different number of neutrons. Next, an iodine isotope is there, which is 131 and 53. It decay by emitting beta. An isotope of xenon is formed. Emission is there because the radioactive isotope can emit out radiation such as alpha, beta, and gamma. The question is state the number of each type of particle in a neutral atom of iodine 131 and 53. So the nucleon number is equals to 131 and atomic number is equals to proton number is equals to 53. So if you want to find the number of the proton is given by Z. So that is equals to 53. So we will write 53 here. To get the number of the neutrons, that is A minus Z, the nucleon number, which is 131, minus the proton number, which is 53. So 131 minus 53, when we subtract, we'll get 78 neutron. And about the electron, because it's a neutral atom, the neutral atom will have equal number of proton and electron. So if there are 53 protons, then it should have 53 electrons. So that's why 53 electrons will be there. Then another question, the isotope of hydrogen 1 has a proton number 1 and a nucleon number 1. The two isotopes of helium 3 and 4, helium 3 is having proton number 2 and nucleon number 3. Like there's a helium with the proton number 2 and nucleon number 3, and another helium 4 is there which is having proton, because to be an isotope they should have the same number of proton or atomic number but different atomic mass. Complete table 11.1 for a neutral atom of these isotopes. So number of the neutrons. So how we'll get the number of the neutron? That is, we'll subtract. So this will be 3 minus, this will be 3 minus 2, so which is equals to 1. And this is 4 minus 2, so that is equals to 2. To get the number of the electron, we know it's a neutral atom. So if this containing 2 proton, then it should have 2 electron. This also. Then when we compare mass compared to a hydrogen one, so when we compare the mass, so hydrogen mass, the mass of hydrogen is 1. And what is the mass of the helium isotope, first of the isotope, that is 3. So compared to hydrogen, like the mass compared to a neutral atom of a hydrogen, so that is equals to 3 times. And for the other one, when we compare the mass, this is the nucleon number or the mass number. So hydrogen is 1, but this is 4. So what is the mass compared to hydrogen? So that is equals to 4 times. So this is 4 times and this one is 3 times, because 3 multiplied by mass of hydrogen will get helium 3, and 4 multiplied by mass of hydrogen will get helium 4. Then bismuth 214 is a radioactive isotope with a half-life of 20 minutes. The nuclide notation of a bismuth is given 214 and 83. State the composition of the nucleus. Because in the nucleus we have neutron and proton, there is no electron, so we don't have to write anything about electron. So how to get the number of the neutron? When we work out A, the nucleon number is 214 and Z is equals to 83. So to get the number of the neutron, that is A minus Z. So 214 minus 83. So when we subtract, we'll get 131. To get the number of the proton, that is given by Z. So here Z is 83. So number of the protons will be 83. We don't have to say anything about the electron. Why? Because in the question they ask, state the composition of nucleus. Nucleus does not contain electrons, so that's why we don't have to say anything about the electrons. Another question, radon, which is 222, is a radioactive. It can be represented by a symbol 222 and 86. So what is the nucleon number? The nucleon number, or A, is equals to 222. And what is the atomic number or the proton number? That's equal to 86. We have to find for a neutral atom, we have to find and state the number of proton. Number of protons are actually given by Z. So that is equals to how much? It will be equal to 86. To get the number of the neutron, number of neutron is A minus Z. So it will be 222 minus 86. So when we subtract, we'll get 136 neutrons. And to find the electron, because it's a neutral, as I already mentioned, neutral atom. So to be neutral atom, the number of the proton and electron should be equal. That's why we'll write 86 directly. So we did this Rutherford experiment yesterday to find the structure of an atom, and he targeted the gold foil by an alpha particle. He observed most of the alpha particle passed through, few of them deviated, few of them bounced back. And these are the observations, like observation and conclusion we already discussed. Today we'll do the structure questions. So the arrow in the figure 11.1 shows the path of three alpha particles moving toward the gold nuclei in a thin foil. On figure 11.1, complete the path of 3 alpha. Look, the first one is moving directly towards. So if it is moving directly towards, what will happen? It will bounce back. The second one is moving closer to the nucleus. So if it is moving closer to the nucleus, it will repel, because there is a repulsion, like charges repel each other, so it will deviate. And the third one, the bottom one, it is moving far from the nucleus, so it will pass straight. So one will deviate, one will change its direction, one will bounce back, and another one will pass straight. Then another one, figure 11.1 shows the path of three alpha particles which are moving towards the gold foil. The particle A is moving directly towards, so basically it is hitting the gold nuclei. So if the particle A is hitting the gold nuclei, what will happen? It will bounce back. The particle is B is moving along a line which is close to the gold nucleus. So if it is passing closer to the gold nuclei, so it will deviate. You can show a deviation up or you can show a deviation down. That is both ways it is correct. And the particle C is moving along a line which does not passes close to the gold nucleus. Like the alpha particle C is not closer to the gold nuclei. So if the particle is not closer to the gold nuclei, as a result, what will happen? It will pass straight. So one will bounce back, one will deviate, another one will pass straight. So on figure 11.1, complete the path we already did. Then state how the result of such experiment using a large number of alpha particle provide evidence of existence of a nuclei. So how we know that there is a nucleus present from this experiment? So basically what you have to do, you have to write the conclusion, the observation and the conclusion of the Rutherford experiment. So what were the observation? That few deflected, or most of them passed through, shows major portion of atom is empty, or most part of the atom is empty. Or you can also say, so most part of the atom is empty, you can say this. Or you can also say that the size of the nucleus is negligible as compared to size of the atom. Then few of them deflected. So what it shows, few of them deflected at a small angle, or few scattered. So what it shows that nucleus contain charge. There is a charge on the nucleus, that's why few of them deflected. And few bounce back. or few of them are reflected, or you can say scattered, shows mass is present inside the nucleus. So these are the observations and the conclusion of the Rutherford experiment. The next question, figure 9.1 shows beam of alpha particle moving towards a thin sheet of a gold in a vacuum. The detector in the region surrounding the thin gold foil. So what happened? Detector recorded deviation, like detector recorded some of them are passing through, few of them deviated, and few of them bounce back. So the detector in the region surrounding the thin gold sheet detects an alpha particle and determines the number of particles that travel in the various directions. State and explain what can be deduced from the following observations. So what we can say about this following observation, majority of the alpha particle are able to pass through a gold sheet undifractedly and they are detected on the far side. Like most of the alpha particles are able to pass through. This is what happened. So what we can say about this, if most of the alpha particle pass through, so what we can say the the nucleus is very small, that we can deduce, that is our conclusion. The size of the nucleus is very small and very few alpha, that's why most of the alpha particles are able to pass through. So the first part is a deduction, like what we deduce that the size of the nucleus is very small, that we deduce, that we conclude. And why we conclude like this? Because there is no interaction or very few interaction between the alpha particles and the nucleus. The second one, small number of the alpha particles are deflected as they pass through a gold sheet. So like small number of alpha particle, when it pass, they deflected. So what we say about this? We say nucleus is a charge and alpha particle experience a force. That's why they are changing the path. And the third one, a very small amount of alpha particle are deflected through a large angle, like they bounce back or deflected through a large angle. So what it shows mass is present in the center, or alpha particle hit the nucleus. That's why they changes the direction. So we have to write these answers. So what we deduce from the first one, the majority of the alpha particles are able to pass through the gold sheet. So what we say the nucleus is very small compared to atom. An explanation for that, that alpha particles does not interact with nucleus, like it does not interact with the nucleus and went straight, does not change the direction. So it shows that most part of the atom is empty. Then the second one, a small number of alpha particles are deflected. Like why this happened? So why this happens? Small number of alpha particles are. It shows that the nucleus is charged. And the reason explanation, that alpha particle experience the force so these alpha particles repelled by the nucleus. That's why the alpha particles deviate or changes the path. And the third one, very small, deflected through a large angle. So what it shows? It shows the mass is present in the nucleus. Nucleus contain a mass. And the alpha particles hit the nucleus or interact with the nucleus, or alpha particles directly moving towards the nucleus. So that's why these alpha particles are able to bounce back. So why they pass straight? Because major portion of the atom is empty. That's why they pass straight. Why they change the direction? Because they experience a repulsion. And why they bounce back? Because they collide or hit the nucleus of an atom. So these were the questions related to nuclear atom.